Hello and welcome to the AIM webinar series. AIM is an alliance enabling the cooperation, development, and standardization of AIDC technologies. From barcodes to RFID to IoT, AIM is your advocate. Any organization with an interest in data collection is a beneficiary of these efforts. Membership provides an opportunity to influence the direction of the industry, develop policies and standards, access market reports, and engage new partners. Before we get started, there are a few housekeeping items I would like to go over. First is our antitrust policy. It's the policy of AIM to conduct its operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. And our collaboration and work product policy states that committee meetings as well as webinars are held for the primary purpose of advancements in our industry, which necessarily involves development of work product intended solely for the public domain. AIM's developed this policy for the protection of its members who engage in this important collaborative effort. You will also notice that you are muted. You'll be muted throughout the webinar. If you have any questions for our presenter, you can send those to me through the Q&A option, which is located at the bottom of your application screen. We'll answer questions at the end of the webinar. Also, this webinar will be recorded and you'll be emailed when it is available. Today, I'm here with Christian Miras, Business Development Manager of IoT Identification Technologies for HID Global. Christian will be going over their 2022 RFID Industrial AIM case study competition winning technology, optimizing hydropower generators with passive RFID sensor tags. Christian, take it away.
Thank you, Mike. Good morning or good evening, depending on where you are in the world. And thanks to join this webinar. Let me just reintroduce myself. My name is Christian Miras. I'm Business Development Manager at HID Global. I'm working for the business area called IDT for Identification Technologies. And in this business area, there are different business units, and one of them is called ISC for Industrial Smart Component. I'm based in Switzerland, in the French part of Switzerland. That's the reason of my strange accent. But that's it. So. I'm working at HID since 2009, and I'm working with RFID for more than 20 years. Now, coming back to the purpose of this seminar, as you know, with, I will say, all the geopolitics issue we are facing currently, there are more and more rumors that we could face some blackout or some electricity blackout this next winter in Europe. And electricity production is a big theme. Now the question is, how can RFID help this industry? This is what I would like to try to answer during this presentation. I have a small agenda, who we are. As it's a three-party project, I will present the different actors in this project. Then I will go to what is passive sensing to explain how it works. Passive sensing versus active sensing, main difference between the both technologies. What was the problem to solve, the issue and constraint facing to solve this and what was the solution, how the problem has been solved. At the end also some how the products, what is the product developed to solve this problematic. And finally, I will go through a small conclusion. As I said, in this project, there are three companies working in the project. Let's start with, I will say, HID Global, where I belongs to. HID Global is part of ASSA ABLOY, who is the global leader in door opening solutions, operating in more than 70 countries. Roughly 51,000 people work for ASSA ABLOY, and the revenue is above $11 billion. As I said, HID Global is part of ASSA ABLOY and one of the top recognized brands for access control worldwide. with headquarters in Austin, Texas. More than 4,500 people are working around the world for HID Global. HID Global produced around 35 million transponder per month, and we don't supply to retail market. So we don't do this kind of small labels for retail market. This is just to, I would say, to show the size of the production that we have. Now, HID Global is divided in different business area, and one of them, as I said before, is called IDT for Identification Technologies. In this business area, we design, develop, produce smart components going from passive to active tags, enabling identification solutions through services like trusted tag, location service, textile service, and many others. Then we have a customer. In this case is GE Hydro. GE Hydro is a subsidiary of GE Renewable Energy with a broad portfolio in the hydropower industry. More than 40,000 employees working in more than 80 countries for a revenue over $16 billion. And finally, we have Assign, who is the chip manufacturer with headquarters in Grenoble, France. Assign provide products and design service to semiconductors IDMs. They launched the AES 321X series, a UHF RFID chip enabling batteryless sensing application. And this was one of the key points in the project, as you will see in the coming slides. Now, what is passive sensing? As you know, sensors measure parameters and deliver data about objects and environments. Passive sensing devices are first wireless and second battery-free sensor. This eliminates maintenance, no need to change or recharge the battery, and can be placed in almost any environment, as you can have ruggedized housing without any openings. It will be water and chemical proof. And at last but not least, no wire connection. Then how it works. Passive sensor tags start to transmit data when the reader energizes the tag, sending data back to the reader every time the sensor is read. To summary, the core of the technology is the IC that detects the environmental changes and transmit those information to the reader using radio frequency energy and communication. To give you an overview about different technology between the passive versus the active sensor. Here is a table showing the main difference between the two technologies. As I said, power source is one of the main difference. Passive, the reader energizer tag. Active, you have a battery. Regarding the read range, there is also a difference between passive using backscattering communication, where you can go up to 6 meters in comparison with active, that where you can go up to multiple kilometers or miles, depending on the communication technology used, like, for example, LoRaWAN or Sigfox or 5G. Regarding the lifespan, as there is no battery, the tag can last lifetime of the application versus the active until the battery dies or needs to be recharged. Regarding maintenance, passive is more in a set and forget mode versus maintenance and replacement due to battery use for the active version. For the other feature like size, robustness, and surface, it's quite the same. Maybe for passive, you can easier embed the tag in some application because it's small. I will say it's slightly smaller or thinner. At the end, the cost for passive, as you don't have the battery, it will be slightly cheaper. What was the problem to solve? Hydropower is one of the oldest and largest form of renewable energy. Is using moving water to generate electricity. The installation are located in server environment where you can have aging connection between the rotor pole or silent poles on the generator. Which at the end can bring a temperature rise, and this can have unplanned failure and production stops. This rotating connection, you have to imagine that it turns up to 800 turns per minute, are subject to significant radial acceleration, so no battery and no wire connection can be used. Due to the fact also that these connections are made of metal or copper, as well as the high speed the tag is transiting in front of the antenna. I will say it's when you can imagine that the tag is going up to 250 kilometers per hour, or it's 155 miles per hour in front of the antenna. So you have really small time to read the tag. To this, we can add also the temperature going over 100 degrees C or 212 degrees Fahrenheit. All these are challenges by themselves to develop and to build an RFID tag. Here the solution. I will start with the global solution going from left to right. We have the plant, meaning the place where you have the hydropower generator. On these generators, on the rotor itself, the big blue part on the left, you have the RFID tags with the sensor. You have also other sensors to measure the speed or the pressure and many other values used for the plant monitoring. All these data are collected via the Hydro Edge platform and sent to the GE cloud. The data aggregation and modeling happens through the GE Asset Platform Management called APM. This software uses machine learning analytics with local context and parameters such as ambient and startup temperature or seasonal effect. Finally, the data can be managed and displayed and helps for preventing maintenance to avoid production stops. Because, you know, in this case, it will cost a lot of money, and it will, the stops when you have this kind of I will say damage on the rotor, it will take a long time to do to repair them. Let's focus on the part where RFID comes into action. Due to the fact there is this fast rotating part, wire or infrared sensor will not work. To this, the advantage of the RFID tag is that you can use any standard UHF rain reader to read and process the data. The passive RFID sensor tag are used to measure the temperature, and in the newest version, also the strain on the rotor poles. Battery-free operation and rigid design allows this long-term operation. Fast temperature reading, you have to imagine that the tag is not more than 10 milliseconds in front of the reader antenna. This means that during that time, you have to power up the chip. The chip needs to measure the temperature and then to send back to the EPC with this value. and all this in roughly less than 10 milliseconds. Let's talk about the product, the RFID tag. Due to the different environmental constraints like metal, temperature, size, it was a certain challenge to design the tag. At the end, we got a tag in a small size factor, 90 millimeter by 27 millimeter by 7 millimeter. The antenna design has been made for a metal application. And also the temperature was challenging, especially for the higher temperature of 100 degree C or 248 degree Fahrenheit. The chip used is the Assign AS3213. I will come more in detail about this chip in another slide. In the first version, we measured only the temperature. In the latest version, we can also measure the strain. The reading distance on metal is up to 4 meters or 13 feet. The tag is batteryless and fully harvested from the RF field on the reader. The tag is not made of a hard plastic, but we use a more flexible material, so the tag fits very well the metallic part where it is applied. Also, the tag isn't screw or rivet, it's glued to have a perfect thermal contact with the metallic part to measure. Going to the chip, as I said before, we used an assigned chip, the AS3213S. This chip can measure temperature and strain. The measurements are done directly on the chip. For both values, there is no external gauge. Due to the fact that to do the measurements, you need more energy than a simple UHF range chip. The sensitivity is limited at minus 13 dBm. The chip is compatible with the usual UHF norm like RAIN RFID, ISO 8006C or EPC Class 1 Gen 2. The data captured or measured are available in the EPC for fast reading process. The chip embedded 512 bits EEPROM memory organized in 4 banks as described in the EPC Gen 2 norm. The silicon is quite small. It's 1.44 mm by 1.68 mm. Main interesting feature is the extended operating temperature from minus 40 degrees C or minus 40 degree Fahrenheit up to 100 degree C or 248 degree Fahrenheit. Usually standard UHF chips are limited to 85 degrees C or 185 degree Fahrenheit. Temperature measurements is linear on the full range with a resolution of plus minus 0.35 degrees C and an accuracy of plus minus 0.7 degrees C. Just to remember difference between accuracy and resolution. Accuracy is how close a reported measurement is to the true value being measured, and resolution is the smallest change or step that can be measured. So in conclusion, with this technology, GE Hydro is able to monitor the different critical values so that the customer can push the hydropower equipment to its limits, avoiding risk of damage or failure in the rotor pole connection. And this will help to enhance network power factor. This technology can also be used in other applications like bridge or building structure and is not only limited to this hydropower use case. I'm at the end of my presentation and hope it was interesting and it gives you some new application ideas. So thank you, and back to you, Mike.
Yeah, thank you, Christian. Really appreciate it. We still have time for people to add their questions if you'd like. If you go to the bottom of your application screen, there's a chat and a Q&A option. You could use either one of those to send your questions to Christian, but I'll get started with the Q&A here. To start, at which distance is the tag read?
In this application, the tag was so the distance between the reader antenna and the tag is about 1.5 meter, around 4.9 feet.
Great, thank you. Another question we have is what kind of antenna and readers are used in the application?
In this application, the antenna used was a Sentis, a Sense RF 101. And the reader is really a standard reader from Impinj, Speedway R420.
Does the containing have other integrated sensors?
Yes, the chip contains other sensors like ELS for ambient light sensors. As I said already before, it's train, and you have electrical continuity. This means that you can do some, for example, a tamper loop. You can imagine to have a tag where you have a kind of wire loop. And when you break the loop, then the tag will say, okay, it was open. And there is also a possibility to have the chip with a hole detector. The hole detector is for magnetic field detection.
And where is the application being deployed?
The application is currently deployed in North America and in Europe in different plans. Due to some confidentiality, I cannot give the exact location, but it's already in North America and Europe.
Okay, great. So this question kind of goes along with that. In your opinion, what are some other applications this could be deployed in?
Depending on the sensor that you use, but you can imagine to use it. For example, if you for temperature, we can imagine also to when you have concrete application, when you use concrete, to be sure that the concrete will be dry, you could use it. So in building application, for I will say ambient light sensor, we could imagine to have some tags in a room or in some places where you need to be sure that the light is switched off or that there is no ambient light or some daylight that comes in. Yeah, and and for other application, I think a lot of place where you need to have this temperature monitoring on a site, for example. Sometimes it's easier to have this kind of battery-less tags, less maintenance, as I said before. So instead to have active tags with battery, where you need also sometimes more, I would say, readers or this kind of things to read it or to receive the information.
Thank you. I'm going to combine a couple questions here together because they're asking pretty much the same thing. What were the main challenges to overcome to make this project successful?
There was, I will say, the first one was to find a chip that can support this 120 degrees C in operating. Usually, as I said before, quite all the chips in the market are more limited to 85 degrees C. And this was one of the point, because in this application, the temperature can go up or over 100 degrees C. And this was one of the challenge. The other one was how to bring, or how to be sure that you transmit, or that you read the right temperature, and not the, I will say, some ambient temperature, to be sure that the temperature is well diffused to the tag and to the chip to read this temperature. This was one of the challenge, was to use the right material and to place the chip correctly in the tag to do this.
Great, thank you.
I don't know if I answered the question, but.
And how do you avoid the magnetic interference?
Magnet interference, there is no, I will say it's not directly magnet interference, because we have a RF field. It's not directly, it's not directly there is a modulation around this field, and this change in comparison to a magnet, there is no modulation, so this will not influence the reading.
Great. And
I don't know if this was the question, or because for example, in this kind of generator, yes, you have some you have a magnetic field inside, but this is constant. There is no changes on the magnetic field, and this has no effect directly on the tag and on the reading performances.
And again, I'm going to combine a couple questions here. What is the material used for the tag and antenna?
So the tag itself, the material is a kind of neoprene material. So it's flexible in comparison to use ABS or PC housing. And inside the antenna, it's a mix between PCB and other structures. Other structures, it's a little bit, I will not give all the details.
Yeah. And then are you aware of what type of tests that were conducted to make sure of the ruggedness?
Yes, there were done different tests. First of all, the GE has a plan where they can do a real test, meaning they can push rotation to go over the speed to be sure that you are still able to read them. They have also possibility to do some heating, I will say heating process, to see how the tag will answer during this heating process, and also to be sure that everything is conform to what they need and what they ask to fulfill.
Okay, great. And how often is the tag read?
The tag is read. Good question. It will depend on the size of the generator, because sometimes you have generator, or maybe they have maybe two, I will say 2 meter diameter up to 4 or 5 meter diameter. And then you can imagine that the tag is not going at the same speed in front of the antenna, but during this time the tag is read at least 2 or 3 times.
Okay, great. That looks like we've answered all the questions here. So Christian, thank you again for your time and insights today. Greatly appreciated.
Thank you. Hope it was interesting.
And thank you to our audience for their active participation. Thanks everyone, and enjoy the rest of your day.
Thank you. Goodbye.